All right. So left you with this. So real quick, big picture. If you have two objects moving independently of each other, you need a list of a list of variables and an equation for each object. Big picture. Okay. So we had the bear, and we had an expression um, 6 meters per second is equal to 26 meters plus the displacement of the tourist over the time. And we had the tourist is an expression of 4 meters per second is equal to displacement of the tourist over the time. I think that's where I left. Is that yes? Is that everybody good there?
It wasn't exactly that.
Wasn't? Is that not as far as I got? Is that good? Okay. So at this point, how many unknowns do I have? Two unknowns. Are we good there? So in math class, if I have two unknowns, what do I need? Two equations. Guess what? Got two equations. With that, so what I can do a lot of different things. I'm just going to pick one of the multiple correct ways to do it. So I'm looking for delta x. So what I need to do is get rid of delta t. So what I'm going to do, so again, one of the multiple ways to do that, I'm going to set both of them equal to delta t. And then set the two equations equal to each other. That's what I'm, one of the multiple different ways. Now, if you ever have, this is a general statement, piece of advice, if you ever have an unknown in the denominator, this is a source for a lot of errors. My recommendation to alleviate those errors, like to not fall in that pit, is to get the unknown out of the denominator. So what I'm going to do is I'm going to multiply, and I find that same thing here, I'm going to multiply t on both sides, delta t on both sides. Okay, so that gets rid of that. So I get 4 delta t is equal to delta x. Do the same thing over here. So you have 6 delta t equal to 26 plus delta x. Good. I want to solve for delta t. So I'm going to divide by 4 on both sides. Now, I do not expect you to write out everything that I'm writing. I'm just doing this to teach. Does that make sense? Okay. Just trying to be explicit here. We're going to do the same thing here. So I get delta t is equal to 26 plus delta x over 6. Solid? Okay. Now, both expressions are equal to delta t, so what I can do, what that enables me to do, is I can set both of these up equal to each other. How many unknowns do I have? uno. You see why I did what I did. Okay? I only have one unknown, and that's what I'm looking for. So at this point in time, I'm going to cross multiply. Going to distribute my 4. Beat me to the answer. How to do. Delta axis over to one side. So I'm subtracting, yes, and then dividing by 2. Now, before we box our answer and walk away, I need a unit. What's my unit? Meters. And then one last thing before I walk away. I want you to ask yourself, does this answer make sense? Is this in the realm of reality? Okay. One of the cool things about physics is it represents stuff in real life. So you're looking at that going 52 meters. That's roughly 50 meters. That's close to 50 yards. That's half of a football field. Is that within the realm of possible? Was it 5 miles? Was it 5 inches? Okay, yeah, could see that. Does that make sense? What I'm that's the looking at is the answer ridiculous? That's what I'm asking. No, I could be. Now you can walk away. Okay. So that is the tried and true way. That is like the hardcore math way. There is an intuitive way that's hard to teach. I'm not going to try to teach it, but I will accept the intuition. Okay, so you have 6 meters a second, 4 meters per second, and there's a 26 meter head start for the tourist. The intuitive way is to say, hey, look, the bear runs 2 meters per second faster than the tourist and has a 26 meter gap to close. Well, every second that goes by, the bear gains 2 meters. So it'd take 13 seconds to make up this 26 meter difference. You all right with that? And in 13 seconds, how far did the tourist run? Well, 4 meters a second times the 13 seconds gives you 52 meters. If you were able to figure that out by yourself, that's great. That's fine. Just make sure you can explain it. You can write down here's what I did. Why I did it. Totally fine with that. If that didn't come to you, that's fine. Do the tried and true route. I will give you this warning though. Your intuition will fail you next unit. This unit's fine because you've dealt with problems like this for several years now in your math class. Okay, you're used to thinking like, oh, you've come up with the relationships. The stuff that we're going to go into, you haven't, and you're going to need to get used to the math. Good with that? Yep. Any questions there? How are we feeling? Big picture, you have different objects, write out your variables and an equation for each one. See what you have, and then try to figure out the relationships between those. Okay? So, hopefully you feel like I just pulled you out of the deep end. Like, here's how you do that. Okay? I mean, it is math, so I don't know. Maybe a little rusty on the algebra. Yeah, maybe. All right. Go for a jog at a pace of 4 meters a second for 20 minutes, and then walk at a pace of 2 meters a second for 20 minutes. What is your average velocity for the entire workout? All right. So, in a similar fashion, last time we had a bear and a tourist. We had two different objects moving. Here, we have the same object, but there's two different stages, multiple stages of the journey. What you want is a list of variables and an equation for each stage. So you want the jogging phase and the walking phase. Does that make sense? So like, what I'm hoping is you see the big picture of if you have different things going on, you need to organize your stuff. Like, hey, here's the walking, here's the jogging. Hey, here's the bear, here's the tourist. Okay, we're seeing that big picture. How to organize, how to approach things like, multiple pieces, multiple parts. Yeah. So, you need a jogging phase. We've got the velocity of 4 meters per second and a time of 2 minutes. I need to convert that to seconds, though. Sorry, not 2 minutes, 20 minutes. Not much of a workout. 20 minutes. I need to convert that to seconds. Is everybody okay with 1,200 seconds? 20 times 60. Okay. You do the walking side. Good. Now, we've organized the stuff that we've been given. Okay. Now we're looking at, okay, what am I looking for? What is the average velocity for the entire workout? I'm like, interesting. That looks at the total, the entire workout. So average velocity, that's equal to your total displacement of the entire workout over your total time of the entire workout. Like that. That. Where are you going to get your total from? Well, it's the total distance of your jogging plus the total distance of your walking. Your total time, where is that going to come from? Same thing. The total time of your jogging plus the total time, the time of your walking. So I don't want you to get freaked out by the alphabet soup. Okay? Average velocity, total displacement over total time. Where we're going to find that? Well, that's just the how far you traveled when jogging plus how far you went walking. Over the total time, well, that's how long you went walking and how long you went walking. Sorry, how long you went jogging and how much time it took for your walking. Are we seeing that? Okay. Now, I've got numbers for this, but where am I going to find those? Yep. I can figure that out by using this equation, right? This is just velocity of the jogging is equal to displacement of the jogging over the time of the jogging. Okay? I've got all that stuff. We got 4 meters per second is equal to displacement of the jog over 1,200 seconds. So I find my displacement of jogging to be equal to 4,800 meters. Right? You figure out displacement of the walking. Beat me to the answer. We're going to give it 2,400 meters. Good? Okay. So now I've got all the pieces of the puzzle. I just need to put it together. I've got my average velocity is equal to displacement of jogging is 4,800 meters. And displacement of my walking is 2,400 meters. Over total time 1200 during the jogging phase, and 1200 during the walking phase. Yes? Average 7,200 meters over 2,400 seconds. And that gives me 3 seconds. Seriously, Mr. Smiley? We went through all that. I could have just said, the average of 4 and 2 is 3. Come on, seriously. Okay. What I'm trying to do is show you how to approach. This is a simple question. I'm showing you how to approach something simple. I'm using a simple example to show you how to approach something even when it gets hard. Okay. It's like converting your 30 eggs to dozen. We had a long conversation about that. Okay. Good with that? How we doing? Big picture, multiple stages, and then total combination of the two. Good? So if I change the question up, you're going to have to read through the dry erase marker stuff. Apologize. You go on a 100-mile long road trip. The first 50 miles, you're going 80 miles an hour. And for the last 50 miles, you're going 60 miles an hour. What is your average speed, assuming no pit stops? Is it more or less or the same, or more or less or equal to 70 miles an hour? What you think first? So you're going on I-65, get to Indy, and then you have to make it through the back roads of like Hoosier National Forest, trying to get through. Okay. For the entire trip, what is your average velocity? Have a conversation. Let's see.
I don't like clothes. Oh, you do? I like some icing, yeah.
Okay, popular answers are A, less than 70, B, equal to 70. How many people say A, less than 70? How many people say B? Okay. Stink. You're all wrong. All right, correct answer is A. So, try to figure out why it would be less than 70. Have discuss amongst yourselves. Why do you think it's less than 70? What is the difference between this scenario that I gave you here and this scenario here? What's the difference? This one was straight up the average of 3 meters a second. This one is less than. Talk to yourselves. Talk amongst yourselves.
Or are you just like running red? What happened?
Okay, for the sake of time, what's the difference between this one and that one? Okay, you're on the right track. The response was there's no time.
The times aren't even.
Right, the times are not even. The times are even here. The times are not even. What's equal? What's even here? The distance. Okay? Think about this. You spend a whole lot longer time going from Indianapolis down to here than you do from here to here. Does that make sense? Because you're going faster. So there's more data points saying you're going 60 miles an hour. You're spending more time going 60 miles an hour than you are going 80 miles an hour. That's going to cause your average to be less. It's like having more test scores 60% and less 80%. Your average isn't going to be 70, it's going to be a little less than 70. You okay with that? If I were to ask you, hey, I want you to solve for the average speed, we would do it the exact same way. Set it up exactly the same way. The only difference is we would know the distance, 50 miles. We wouldn't know the time. We'd have to solve for it. Okay? Same thing here. And then you would take those numbers, those times that you found, you would know this is 100 miles. But you need to find the time for each part. And then when you do that, you'd find it to be like 68 something miles an hour. Good with that? Okay. The rest of the time is yours. We're on activity schedule. So we're out of here at 9:50. So you got 10 minutes. You can print off or just use your notebook piece of paper.